Hi everyone, I'm Dr. Surjit Singh. Today we'll talk about the Leetcode problem on maximum path sum in a binary tree. Welcome to my first video on trees. Let us begin. We are given a binary tree. We are to find a path in the tree for which the sum is maximum. By definition of a tree, there is one and only one path between every pair of nodes. The brute force method is to find all these paths and path sums and compare all these sums to find the maximum out of these values. This method takes time of the order of n squared. So we won't proceed with this discussion and design a better approach. Now we consider a recursive DFS method. Before we start writing the program of this problem, let us discuss some examples. Consider a tree with a single node. It means that both of its links are none, for which contributions are 0, and the path sum of this tree is 8. Now we consider this tree. The root node is 8, its left gain is 5, while the right gain is 3. So the path sum of the three nodes is 16. Now consider another example. In this, the left gain is 5, but the right gain is 0 because the gain cannot be negative. So the maximum path sum is of the two nodes. The path sum is 13. Now in this example, the left gain is 5, while the right gain can be 12 or 17. The higher of these is 17. Gain is the node value, that is minus 3, plus higher of its left and right gains, that are 15 and 20. So with 8 as the starting node, maximum path sum is of 4 nodes, 8 plus 5 plus minus 3 plus 20, which is equal to 30. But this is not the end of the story. For the subtree with minus 3 as the root, its left gain is 15 and the right gain is 20, and the path sum of these three nodes is 32. So maximum path sum for this tree is 32 and not 30. When we start with the root as the node, the path sum is 30, but when we repeat the process with its right child, the path sum is 32. So starting with the root, we recursively process all the nodes of the tree to find the various path sums. Highest out of these sums is the required result. Let us now write the Python program for max path sum. Consider the same tree with these 5 nodes. Root node is 8. We will process all the nodes of the tree recursively. The recursive function gainFrom finds the gain contributed by a subtree to its parent. For example, with 8 as the root, gain from its left subtree is 5, and gain from its right subtree with node minus 3 is 17. With this introduction, let us develop the function gainFrom. If the node is none, the gain from it is 0. Otherwise, let us find gain from its two child nodes. Gain left is found from the left child by applying the same recursive function. But we ensure that the gain is not negative by taking its max with 0. Similarly, gain right is obtained from the right child. Path sum is the node value plus gain left plus gain right. This value is 32 in this case. However, the return value is the gain from the node to its parent. This is the node value plus higher of the gains from its two children. With this, the recursive skeleton is ready. We call this function with root as the starting node. DFS recursion will traverse each node once. In each recursion, we consider one node and find path sum for the subtree that has the node as the root. However, we are yet to compare them all to find the max path sum. We will now insert statements for this purpose. First, we define a variable maxsum outside of the recursive function and initialize it to -infinity. In order to use this variable inside of the recursive function, we have to declare it as non-local variable in the recursive function. In every iteration, we compare pathsum with maxsum and save higher of the two in maxsum. After processing all the nodes, we return the final value of maxsum as the output. The program is now ready, and let us perform its dry run. Root is the parameter of the function maxPathSum. We define the variable maxsum with -infinity as initial value. After the def statement, next executable statement is gain from at the green mark, which initiates the execution of recursive function with root as the node. As the node is not none, the first if statement is skipped. Recursion is called at two places within the recursive function. First call is at white mark, where the value is assigned to gain left. The left child of the node is 5, which becomes the node in the next call. Once again, node is not none, and we again reach the statement with white mark. This time, left child is none, which becomes node in this call. So the if statement becomes true and the function returns 0, which is stored at gain left in the previous call of the function. Next, we execute the statement with the orange mark. Its output will be assigned to gain right. Right child is also none, so the recursion will again return the value 0, which becomes the value of gain right. Pathsum is sum of node plus these two gains, which is 5. As this value is more than the previous value of maxsum, so maxsum becomes 5. Return value is the node value plus higher of the two gains, which is 5. So gain left at white mark of the previous call becomes 5. Right child of node is -3. In order to find gain right, we execute the statement with orange mark with this node -3. Node is not none, so we reach the statement with white mark to find gain left of -3. Left child is 15, so we call function gain from again with 15, which becomes the new node. Left child of 15 is none, so function returns 0, which is stored in gain left. Similarly, at the next statement, gain right also becomes 0. Pathsum is 15, which is higher than maxsum, so maxsum becomes 15, and the function returns 15, which becomes gain left of the previous call. Now let us find the gain right of -3. Right node of -3 is 20. Both the children of 20 are none, so both the gains of 20 are 0, and pathsum becomes 20. This is greater than old value of maxsum, so new maxsum is 20. The return value is also 20, which becomes gain right for the previous call. Pathsum is the sum of these three values, which becomes 32. This replaces the old value of maxsum. Return value is the node value plus higher of the two gains, for which the return is 17. So 17 becomes the gain right of the first call of the function. Pathsum for this comes out to be 30. This value is less than maximum, so it is not saved there. Return value of this call brings us back to the green statement. We come out of recursion and the call stack is cleared. Maxsum is defined outside of the recursive function, so its value stays. This value is returned as the final result. Each node is processed once in the program, so the time complexity is of the order of n. Each node is saved in the call stack. So working memory is of the order of the height of the tree, for which the maximum value is n. Thank you for your time. Please stay tuned for more such videos.